But did you get the last point or did you not get the last point? Should I repeat it again? So what happens in convex functions? Convex function, this is, I'm not saying the exact definition to convex function is this, but for the continuously differential function, like for example, the sine theta is an infinitely differential function. So here I can just take the second derivative and find whether the function is convex or not. Okay, so there is a lot more rigor associated to theory of convex functions, and in fact, you'll find that this is a very important branch of mathematics. Also, eventually, this convexity of functions leads to something called as convex optimization. Also, so overall, you just need to understand that if at all I'm saying your function is convex, that implies your f double dash theta should be greater than zero only if your function's second order derivative is defined. Okay, so sine theta is infinitely differential function. I differentiated it. I'll get sine minus sine theta, and so this is less than zero. And what is the beauty of concave function is the concave function. If you try to make the curve, if you try to make a curve of a concave function, the curve always lies above the line joining the two. For example, if I'm joining a chord from here to here, the curve always lie above. So this is the definition of the concave function. So from 0 to pi by 2, you can clearly see that your sine theta second derivative is negative. So sine theta happens to be a concave function. So let us join a line from 0 to pi by 2. So at pi by 2, the value would be equal to pi by 2 comma 1 only, right? So coordinates will be pi by 2 comma 1. So this line will be 0 comma 0 to pi by 2 comma 1. You just find this will come out as this line. This line will lie below sine theta. So I will write sine theta is less than equal to 2 theta upon pi. Is that clear? Bharat, is that clear to you?
Sir, that line lies below the sine theta curve. So sine theta should be greater than equal to 2 theta by pi.
Sorry. My mistake. Sine theta should be greater than equal to 2 theta by pi. So if I multiply with minus mr sine theta, can I not write it as minus mr 2 theta upon pi? And if I write in this fashion, minus e ki power minus mr sine theta should be less than equal to e ki power minus mr 2 theta upon pi. Is that clear? So I'll write it as integral 0 से लेकर pi by 2 e की power minus m r, and here it is 2, here it is theta upon pi, and you have m upon r ki power k minus 1 d theta. Is that clear? And this entire thing, r is a constant. Understand my point that r is a constant. This entire thing would be integrated as theta 10 in the function in some terms of theta, right? I mean, there would be some. I have to integrate it with theta. Your r is a constant. Are you getting my point?
Yes, sir.
Okay. So if I just try to write this entire thing in this fashion, let's say I just take this common out. M is a constant, R is a constant. I'm not bothered about it. I'm not bothered about it. And 0 to pi by 2, e ki power minus 2mr theta upon pi d theta. So this can be integrated, isn't it? So this is like exponential sum minus alpha theta. So this will give you some constant here to r k minus 1 alpha. Here I'm writing this alpha is this entire thing. And you are left with e ki power minus alpha. Is that so? Or some negative also? I'm not interested. And see, as r tends to infinity, your alpha also tends to infinity. And as your alpha tends to infinity, this entire thing would go towards 0. Are you getting my point? Since this entire thing would go towards 0, what does it mean? It means that this integral over the semicircular arc tends to 0 as r tends to infinity. Okay. And this is what I was telling initially, that this particular integral will vanish as r tends to infinity. So this particular integral would vanish as r tends to infinity. So this term would vanish as r tends to infinity. And your integration minus infinity to infinity e ki power iota mx fx dx would be equals to this contour integration. Now your question as to what we'll do for cos mx or sin mx, my suggestion is just try to find this integral. In the entire process, you will encounter cos mx and sin mx both, because see, if you replace cos mx by e ki power iota mz, so you will have some cos term also, and you will have some sin term also. So my suggestion is not initially that you don't do that real and imaginary. Even if you do, the answer would come out as same. But let इसको free छोड़ देते हैं. Let us see hota kya. Are you getting my point? What I need to convey?
Yes, sir.
Okay, so I'll explain you this thing, entire thing with the problem. So ये अभी दोनों चीजों में हमने देखा कि जो सेमी सर्कुलर आर्क के ऊपर इंटीग्रल हो रहा है वो जीरो आ रहा है. So this is the beauty of thing कि ये integration we could not do in from our standard 12th manner. That is the class we have on Riemann integrals. So what we'll do it in a different fashion. We'll try to do this problem using contour integration. Okay, is that clear? Okay, so what I would do is, I'll try to do a problem. So this is my problem, 0 to infinite cos mx upon 1 plus x square dx. Is that clear? So we'll do this problem. So I told you this is something like 1 upon x square, and this is some e की power iota mx का real part है. This is some. अब अगर इसको मैं replace करूं, if I replace it, I have to replace it by contour integration e की power iota mz upon 1 plus z square. Is that so? And this contour integration is over a semicircular contour. And I told you already that integration over this will turn out to be 0. So I'm not interested here. I'm only interested here. And if I'm interested here, eventually I'm finding this integration. Is that clear? And you can also see that z equals to plus minus iota. Only z equal to iota lies inside the contour. Is that clear? Is
Yes,
that
sir.
clear?
With a factor of 1 by 2 also, no, sir, because limits are 0 to.
Again, sorry, my mistakes. Again, a factor of 1 over 2 will also. So let us try to evaluate this integral. Sorry. So I'll evaluate this integral. We'll take a half otherwise. So e की power iota mz upon 1 plus z square dz will come out as minus r to r e की power iota mx upon 1 plus x square dx. And then there will be an integral over the semicircular arc e की power iota mz upon 1 plus z square dz. For another revision, I'll do this integration, this entire evaluation, that this integration would go towards 0, just for your remembrance I'm doing it. This integration would be less than 1 because e की power iota mz का mod is 1, and this will come out as less than 1 minus r square mod. The same thing that I did in the initial step. You can clearly feel that this, as r tends to infinity, will go towards 0. This would go towards 0. This entire mod will go towards, this integral mod would go towards 0. So this entire mod would go towards 0 as r tends to infinity. Is that clear? Okay. Now, what about this integration? On your left, what about this integration? So clearly you can see that I'm evaluating a contour integration. I'm evaluating a contour integration over a closed contour. And there is a singularity which is inside, that is z equal to iota is inside, because as r tends to infinity, this can become as large as possible. So eventually this is equals to 2 pi iota into residue at z equal to iota. So this will be z minus iota into e की power iota mz upon I think z minus iota into z plus iota. So z minus iota gets cancelled with z minus iota, and you're left with this entire thing, and I think it will give you 2 pi iota e की power minus m divided by 2 iota. Iota gets cancelled with iota, 2 gets cancelled with 2. So you're left with pi e की power minus m. Okay, is that clear? So this entire thing will become pi into e की power minus m. What about this term? As r tends to infinity, this will become from minus infinity to plus infinite. So I'll write this also. So on the left hand side, you are having something called as pi into e की power minus m. On the right hand side, you have minus infinite to infinite. E की power iota mx क्या होगा बेटा? Cos mx plus iota mx, iota sin mx divided by 1 plus x square dx. And this term will become 0. I'm not bothered about it. Okay, so overall, I'll find that this integration I was interested in, and I've also gotten a different integration also around it. So this is an advantage here. So what I will do is pi e to power minus m is equals to minus infinite to infinite cos mx upon 1 plus x square dx plus iota integration minus infinite to infinite sine mx upon 1 plus x square dx. Clearly, there is no such iota term. So this integral is nothing but it is equal to what? 0. Is that clear? Because see, on the right hand side, you do not have any iota terms. This integration is 0. And this integration is equal to pi into e to power minus m. Okay. Since this integration is pi into e to power minus m, so the overall integration will come out as pi upon 2 e to power minus m. Is that clear? Overall integration of this will come out as pi upon 2 into e to power minus m. Is that clear? And this is only valid if m is greater than 0. Okay, because if m is not greater than 0, then things will not work. Because if m is, let's say, is negative, then this entire thing will not go towards 0 as z tends to infinity. This will become infinite in that particular case. Is that clear? Bharat, is that clear to you? ये चीज समझ में
Yes,
आई?
sir. Sir, if we are getting answers from left hand side alone, then why we are even bothered about the right hand side integrals?
No, we are not bothered. Just to make you understand, right now I'm doing all those things so that एक दो क्वेश्चन के अंदर तुम्हारा दिमाग ऐसे काम करने लग जाए, है ना? So आंसर तो वही है. Answer तो is like pi e की power minus m. But I just wanted you to understand that this integral goes towards 0. And if you take the real part on the both side, this will give you cos mx upon 1 plus x square. Real part here will give you pi e की power minus m. Just wanted to say that if somebody asks you this question, 0 to infinite sine mx upon 1 plus x square dx, what is the answer? Then it will come out as 0.
Okay, okay, okay.
Is that clear?
Yes, sir.
Okay, one question I'm leaving you as a leaving for you as a homework, not more. But iske bas practice, you have to do a lot amount of practice for such question, because without practice, you won't be able to do it right in the examination. So x into sine pi x upon x square plus 2x plus 5dx. Okay. Now this integration you have to do as a homework. Okay. I should give the answer to it also. Just give me a minute. So answer to it is, if I'm not wrong, so answer to it is minus pi e to power minus 2 pi. Try to solve this question. If it does not, you cannot solve it, then we'll do it. Okay. So we'll go along doing more such questions. Don't worry about it. But right now, my focus is to take you through a brief visit of all sort of integrals that may be possible. Okay. So step by step, I'm taking. The first step was to do a simple integrals which follows only Cauchy's integral theorem. Then we evaluated some multi-valued integrals which integrals that sorry, we extended the क्या कह सकते Cauchy's integral theorem from single valued from क्या कह सकते simply connected region to multiply connected region, and then we did calculus of residues. Then we started doing some integrals. The first integral that we encountered was trigonometric integrals. Then we went on to do different integrals from minus infinity to infinity, fx dx, where fx is some rational function. Then we did this integral where fx is multiplied with sine or cosine. And what can be other possibilities? The other possibility can be like integrals of this type, where you'll find that while evaluation, and this integral is an important integral also, okay? So you'll find it quite often in physics and mathematics at several other places. And if I'm not wrong, this is also called as a Dirichlet integral. I'm not very sure, but sine x upon x dx. So how to find such integration? Because now, if you replace this entire thing by e to power iota z upon z also, you can clearly see that your z equal to 0 is a singularity. and it lies on the contour itself. It lies on the contour itself. So how to do such problems in uh, like I don't believe in any sort of shortcut, because see, even if you do some shortcut also, what is wrong? Even if you don't do a shortcut, see, this integration would always come out as zero. So you do a fair amount of practice, and like you do 10 questions or 12 questions, every time you just try to find this integration, you will find this integration is always tending towards zero. So you should not be bothered. Like you should not learn any special trick for doing this integration. I don't believe in any such short trick. So basically, करो एग्जाम में by the methodology that I have told you. तो थोड़ा सा 1 मिनट ज्यादा लग सकता है एग्जाम में, लेकिन ओवरऑल यू विल end up being on the safer side. हो सकता है कि कभी शॉर्ट ट्रिक लगे ना लगे, आई डोंट नो, देयर आर सम सॉर्ट ऑफ शॉर्ट ट्रिक्स, बट आई डोंट बिलीव इन एनी सॉर्ट ऑफ दोस ट्रिक्स. कितना सा टाइम लगेगा इसको इवैल्यूएट करने में, है ना? इतनी मैथ्स तो आती ही है ना. सो इज दैट क्लियर?
Yes, sir.
Okay, so we are doing this kind of integral, and I don't know what title should I do. I should make a title like miscellaneous integrals or integrals with a singularity enclosed on the contour. I don't know what sort of thing I should say, but um, so miscellaneous I would write it as the miscellaneous integrals that have.
Sir,
So
for
here,
previous cases, we have not discussed anything like if the singularity lies on the contour.
contour itself, right? So now I'm doing that singularity lie on the contour. So that is why I don't know what should I say about these integral. I'm writing them as miscellaneous integrals on the contour itself. Okay. So how to do this problem? This is a fairly important problem, and you'll find that in any MSc entrance exam, or sorry, any MSc program, you'll find that this integral is often asked in the papers, like in the papers that you write for your MSc thing. Okay. Thing is very simple. So what you would do is, you can see that your z equal to 0, you can clearly see that your z equal to 0 is a singularity. Okay, so I'll write it in this fashion. So if I'm to evaluate sin x upon x dx, integral from 0 to infinite. Okay, so I'm supposed to replace it by I'll write it as 1 upon 2 minus infinite. That's the very first thing that I would do. Okay, and I will replace this integration by integration over gamma e की power iota z upon z dz. And what is gamma? Gamma is nothing, but it is equals to a semicircular contour. Okay, is that clear? Now the problem is, when you are going about the semicircular contour, you are getting a singularity here. You're getting a singularity here. Okay, so what to do? So there is you need to indent the curve. You need to transform this curve. You have to do something. Let's say what I will do, I will try to circumvent this singularity problem using a semicircular indentation. So what I would do, I would indent the contour. I would say that I will not cross the singularity, and I will enclose the singularity inside, you can say, a semicircle of radius as small as possible, you may like epsilon. And epsilon tends to as small as possible. As small as possible means epsilon tends to 0. I'm showing you an exaggerated version right here. Okay, so don't get confused. Okay, is that clear? So
Yes,
I would write it as point A. I would write it as point B. I would write it as एक काम करते हैं, कर्व का नाम अगर C दे देंगे तो दिक्कत होगी ना. So I will write it as D. ठीक है, and just writing E here, writing F here, writing G at this point. Okay, writing H at this point, let's say, and just to make you understand things. Okay, so you have a semicircular छोटा semicircle मिल रहा है HJA. Okay, then you have a bada semicircle. I don't know what to say about this. This will be like B, D, E, F, G. Okay, then you have two of these lines, like this line and this line. Okay, is that clear? And understand my point that epsilon tends to 0, as small as possible. It should be as small as possible. So I've just indented the curve. I'm not using this point, but I'm not make ऐसा मत कह देना कि इंटीग्रेशन बहुत चेंज हो जाएगा, नहीं होगा, because I'm just doing a certain I'm just making a semicircular arc of very infinitesimal small radius. So it is not going to change much of your integration, and epsilon is tending towards 0. Is that clear?
Yes.
So this entire thing will become integration. I think if I start from here, minus r, this will be plus r. This is epsilon, so this will be minus epsilon. I think this will be plus epsilon. So minus r to minus epsilon. I'm not writing the integrand inside. I'll write it. So on this, if I write e ki power iota z, or even if I write e ki power iota x, they are one and the same thing. Then integration over hja, which is e ki power iota z upon z dz. Then you have epsilon to r e ki power iota x upon x dx. And then I think you have integration over, what should I write? It is a long term, b d e f g, जो भी है, ठीक है, and e की power iota z upon z dz. Is that clear?
Yes, sir.
Okay, so that's first left. Okay, now we'll see first कि पहले भी हमने देखा कि जो हमारा सेमीसर्कुलर कॉन्टोर के अंदर भी हमने देखा कि जो आर्क के ऊपर इंटीग्रल होता है दैट बिकम्स 0. So we'll be interested to see how this HJA, this integration behaves and this integration behaves. In the limit, epsilon tends to 0 and also r tends to infinity. Because only if r tends to infinity, only then it makes sense. Doing this integration makes sense only if r tends to infinity. Okay? Because only then I can write somehow I can reduce my integration into this sort of integration. Is that clear? So we are evaluating this entire thing in the limit as epsilon tends to 0 and r tends to infinity. Is that clear?
Yes.
So what you can do is, what I would do is, I would take these two integration, like inko, I'll rescue them now. See, I'll take x as minus t here. So do certain calculation in your mind. So I'm taking x as minus t, dx will become minus dt. This will become e ki power minus iota t. This will become r to epsilon, one negative, take common. So this will become epsilon to r. Okay. And epsilon to r e ki power iota x. And this is, I think, again a negative, e ki power minus iota x upon x. And here you have dx. See, again, I'll do it here. देखो, take x is equal to minus t. ठीक है? This integration will become r to epsilon. Dx will become minus dt. Lower term will become minus t. And this term will become e ki power minus iota t. This negative will get absorbed and take a negative common, so that this will become epsilon to r. And whether you say t or whether you say x, one and the same thing if your limits are same. Okay, so this entire thing I have written here. Are you getting my point? And then I have an integration which is over hja, and then I have an integration over bdeg. Sorry, bdeg. And you can see that this integration is nothing but it is equal to epsilon to r to iota common below. This is sine x upon x dx. And there is a left hand side also running. Okay, don't forget that also. This left hand side also is running. I'll write it as LHS. So I'll do LHS separately. And I'm first interested in finding out what these two integration would behave like. Okay, so first I would be interested. हाँ बेटा बोलो.
सर ये दूसरी एक्सपोनेंशियल टर्म कैसे है e टू पावर आयोटा x वाली फर्स्ट वाली?
देखो ये वाली फर्स्ट वाली टर्म, ये दोनों मिला के वाला टर्म.
जी.
देखो ये टर्म पकड़ के रखो, है ना?
आपने
ये
दोनों इंटीग्रल
मर्ज कर दिया, मतलब आई हैव एडेड दीस टू टर्म्स बिकॉज़ द इंटीग्रेशन लिमिट्स आर सेम ना, एप्सिलॉन टू आर ही तो लिमिट. सो एप्सिलॉन टू आर, बस एक नेगेटिव.
राइट सर.
ओके, लेफ्ट हैंड साइड चलते रहना. अच्छा, लेफ्ट हैंड साइड कर ही लेते हैं ना. व्हाट विल बी लेफ्ट हैंड साइड? यू सी नाउ व्हाट इज गामा. गामा आफ्टर इंडेंटेशन, सो आई विल राइट आफ्टर indentation, So after indentation, what is integration over this closed contour gamma? Will it not be 0? Because now this gamma no longer encloses the singularity. Is that clear?
Yes, right.
I will write this as 0 right now. Okay, right away I'll write 0 because then, okay, so I'll write it as 0 here. How should I write? I'll write it as 0 here. Okay, is that मतलब तुम follow कर पा रहे हो ना? Is that clear ना? ये मतलब समझ पा
Yes,
रहे हो ना?
ये तो
Because
theory
I've
में
written
है.
it. Okay, and now we have to find these two integrals. We are interested in these two integrals. So let us do these two integrals first, and then we'll return back to the same equation. So I'm leaving some space and I'm doing some first B, D, E, F, G जो भी है. Integration e की power iota z upon z dz. This is the bigger semicircle. Okay, so this is the bigger semicircle, and we are evaluating it as r tends to infinite and epsilon tends to 0. Okay, so what I would do is I would try to evaluate this integration as r tends to infinite. So as r tends to infinite, e की power iota r e की power iota theta, and this is r iota e की power iota d theta divided by z is I think again r e की power iota theta. Okay, this from 0 to pi. Is that clear? So basically on the upper half of the semicircle, I have any point can be written as r into e की power iota theta, and let us see what will happen to this integration. So just find a mod over it. This will become equal to e की power iota r e की power iota theta mod, and this mod will give you r. This mod will give you r. So I'm not interested. This d theta mod mod integration from the 0 to pi would give you this. Okay, and eventually you're left with e की power minus r e की power iota theta. Iota e की power iota theta क्या होता है? R sin theta iota के साथ and r cos theta. This is e की power iota theta, and you just r e की power iota theta. ठीक है, इसको यहाँ पे रखेंगे तो cos theta वाला term is associated with r, so that will become 1. Only this term minus r sin theta pi. Okay, in any case, theta, if it goes from 0 to pi, also sin theta will lie from -1 to 1. So it will remain finite. This is some finite number. But as r tends to infinite, this overall term will go towards 0. Is that clear? Otherwise, you can follow the same step that I did earlier also. But easier way would be to evaluate this in mod using like a simple argument that sin theta in any case from 0 to pi would remain from -1 to 1 only. Is that clear?
Yes, sir.
Okay, and also you can do that. This integration can be written as 0 to pi by 2, and you can take half common out. Okay, because eventually you are left with integration from 0 to, like, not this integration, this to as a 0 to pi run through, but this integration while you were doing, so I'll write it in complete here. इसको ऐसे कर देते हैं. Okay, now this mod, ठीक है, so instead of writing इसको क्या लिख सकते हैं? You can write it in, I can write it as 0 से लेकर pi e की पावर iota r cos theta minus r sin theta का mod. ठीक है, ये लो. Okay, so otherwise you will get confused. Okay, okay, so यहाँ तक clear है. Now you see that this iota r cos theta का mod will become 1, so you are left with e की पावर minus r sin theta d theta integration from 0 to pi. Okay, is that clear? And हल्का से मैंने अभी पहले पहले भी आइडिया दिया था कि sin pi minus theta is sin theta, so you can write it as pi by 2 half आगे कर दो e की पावर minus r sin theta d theta, and we saw that your sin theta is always greater than equal to 2 theta upon pi, so your minus sin theta will be less than equal to minus 2 theta upon pi, and the same step that I did, and you can clearly see that as r tends to infinite, this will turn towards 0. The same step that I did in the discussion of the previous problems. Is that clear?
Yes, sir.
Now, what about HJA? So HJA I'm evaluating as r tends to infinite and epsilon tends to 0. Okay, so at HJA you can, again I'll come upstairs. इधर देखते हैं. HJA का मतलब क्या है? What I have to evaluate? I have to evaluate HJA, integral over HJA. HJA के ऊपर any point on HJA can be written as, sorry, any point on the HJA can be written as epsilon e की power. I can write any point on HJ as epsilon e की power iota theta. Is that clear? So this will become
Yes, sir.
e की power iota z की जगह epsilon e की power iota theta divided by, I think, epsilon e की power iota theta, if I'm not wrong, and d theta will become iota epsilon e की power iota theta d theta. Iota theta gets cancelled, epsilon get cancelled. Okay, this is clear. And this
Yes.
is all I'm evaluating in the limit epsilon tends to 0. So here it is not r tends to infinite, so I cannot straight away reject this. So I have to keep that also in mind. Also, that while I'm evaluating HJA, uh, while I'm evaluating HJ, I am going in the clockwise direction. Is that clear? I'm not going in the anti-clockwise direction. So this is also something to remember, that I'm going in the clockwise direction. So there should be a negative also. Where should I apply this negative? I'll write here as clock, and I'll write here as minus. Is that clear? Iota comes out. Integration e की power iota epsilon e की power iota theta, and this is d theta. Is that clear?
Yes, sir.
And you can see that this integration depends on theta. Epsilon is just a constant here. Okay. So you can take this limiting value inside also, because see, epsilon eventually is nothing but a constant. So you're not playing anything with variable. And you're saying already that your epsilon tends to 0. So you can take this epsilon inside. Epsilon tends to 0. This entire thing will become e की power 0. And e की power 0 is what? E की power 0 is 1. And this integration will come from minus pi to, sorry, this integration can be written as 0 to pi, because I have already taken a negative outside. So either you take a negative or you don't take a negative. If you don't take a negative, then you just write pi to 0, because the orientation itself suggests that you are moving from
Right, sir.
pi to 0. Like, how should I explain? You're moving from pi to 0. So if you're writing pi to 0, then don't write a negative. But if you're writing 0 to pi, then write a negative. Otherwise, things will become wrong. Is that clear कि मैं कुछ गलती कर रहा हूँ?
सही है सर.
Okay. एक मिनट में तो गलती करी क्या? Because answer negative नहीं आना चाहिए. Just let us see up. Okay, एक मिनट वापस देखते हैं. So what I am doing is, okay, this is HGA. Oh, sorry. This is not anti-clock or clock. See, we are not talking about, this is, sorry, my mistake. I'm not saying clock or anti-clock here, because I'm only talking about, right now I'm talking about arc. So I'm talking about semi-arc, and semi-arc is going from here to here. So basically, either you write pi to, here you write your angle is transforming from pi to 0. So angle is transforming from pi to 0. So if I write my angle is transforming from pi to 0, is that clear? You know, your angle is transforming from pi to 0. Is that clear?
Yes, sir.
Okay. And this orientation sense is, what sort of orientation sense is this? I would say this is a clockwise orientation sense, right? So this is a clockwise orientation sense, if I'm not wrong.
Yes.
Okay. So my mistake. I will have to keep a minus here. So the answer should come as minus limit epsilon tends to 0 iota. And see, because this integration depends only on theta, right? And epsilon is just a parameter, you can say. So I can take this limit inside. So I'll get, I think, e की power 0, and this is d theta. Integration from pi to 0. This will come out as, I think, pi into iota. Is that clear? 0 minus pi is minus, and another minus. Overall total मिला के positive हो जाएगा pi iota. Is that clear?
Yes, sir.
Okay. Is that clear? एक्चुअली दो नेगेटिव आ रहे हैं. एक तो एक्चुअली हो क्या रहा है, जो एंगल है पहले से ही यू आर वेरिंग फ्रॉम, मतलब जब हम एचजे के थ्रू मूव कर रहे हैं तो एंगल हम लोग इस तरीके से चला पाएंगे, नॉट इन दिस फैशन. तो एंगल स्टार्टिंग वाला इनिशियल एंगल बोला जाएगा पाई एंड फाइनल एंगल बोला जाएगा 0. और क्योंकि तुम यू मूव कर रहे हो तो यू विल राइट अगेन अ नेगेटिव, और यू कैन सिंपली नॉट राइट ऑल दीज थिंग्स एंड जस्ट राइट
Absorb
0
the
टू पाई.
minus.
हाँ, एब्जॉर्ब द
Yes, sir.
नेगेटिव साइन एंड जस्ट राइट 0 टू पाई. मतलब समझ रहे हो, नहीं तो इसमें थोड़ा कंफ्यूजन रहेगा. तो यू जस्ट टेक 0 टू पाई एंड जस्ट सॉल्व इट. ओके, इज दैट क्लियर टू यू?
Yes.
Okay, so you will find that this integration has come out as has come out to be, okay. So this integration has come out as, I don't know what is the mistake I'm doing. This integration has come out as pi iota. There is an error with the negative thing. I don't know where it is. What a mistake have I done? Are we taking two negatives or what?
Sir, if you're taking pi to 0 limit, then I think we should not take negative sign.
Right. Because there are two negative then in that particular case, right? Equal.
Yes,
This
sir.
is a mistake that I'm doing. Okay. So what would be the suggestion is, if I'm already traversing anti-clockwise, sorry, if I'm already traversing clockwise, then it means that I'm going from pi to 0 only.
Pi
Okay.
to 0, yes.
Okay. So right, you were right actually. I made a mistake. So eventually I would write it as I think minus pi here, and हाँ, या फिर हम ऐसा कह देते हैं कि आई एम मूविंग फ्रॉम 0 टू पाई एंड आई विल राइट अगेन नेगेटिव. हाँ, तो एक ही बात है ना. सो आई हैव ऑलरेडी टेकन द थीटा वेरिंग फ्रॉम पाई टू 0. सो पाई से 0 मूव करने का मतलब यही हो गया कि आई एम मूविंग क्लॉकवाइज. इज दैट क्लियर? I was just taking two negatives. Why I was
Yes,
taking two
sir.
negatives, I don't know. Okay, so overall, this will become, I think, if I'm not wrong, this will become minus pi iota. Okay, so this is minus pi iota. This is something that we want to evaluate. This is 0. So this will become pi iota is equal to 2 iota. And epsilon tends to 0, this is 0. Epsilon tends to infinity, this will become infinity. And this is sine x upon x dx. So in fact, you don't need to even multiply with half. You're already getting that kind of answer here. So your answer would be equals to pi upon 2. So this integration is very celebrated integration. You will find time and again this integral is asked in examination also. So this is pi upon 2. Is that clear? Little bit long question to do.
Yes.
Okay. So just remember one mistake that I was doing. Just don't get confused by that mistake. I'm reiterating. So what we did was actually I was right, but then I got confused. So I was just saying that if you are moving from pi to 0, then don't write again clockwise, because you are actually doing, when you are writing that your angle is transforming, your angle is going from pi to 0. It itself means that you are moving clockwise. Okay, or you write 0 to pi and then say that my orientation is clockwise, so overall a negative will come out. So in any case, both of the ways you are getting minus pi out. Okay, so I got confused by saying that contour is also moving anti-clockwise. So that is my mistake. So don't get confused by my mistake. Just understand that when I'm moving from here to here, my angle goes from pi to 0. So if I write pi to 0, it itself means that I'm going in anti-clockwise fashion. Is that clear?
Yes, sir.
Okay, so overall the answer to this particular problem comes out as pi by 2. And in exam you have to understand कि क्या याद रखना है. If at all some कुछ दूसरा आ जाए, जैसे sin 2x आ जाए या कुछ ऐसा कुछ आ जाए, just remember that integration on the upper half, on the bigger semicircle is 0. This you can always arrange in examination. This is no big deal. Only thing that you have to do with all कह सकते हैं all sincerity, or you can say with caution, you have to do is this kind of integral, because this is that integral which is going to give you the real answer. Are you getting my point? So for example, if somebody asks you in the examination about this integration sine 2x upon x dx, try to find this integration. Okay, try to find this integration. Okay, so we'll tomorrow move to Fresnel integrals and we'll go along. I hope I'm able to explain the things, right? Is that clear?
Yes, sir.
ओके, थोड़ा सा कहीं बीच पे मिसमैच हो जाता है, आई डोंट नो व्हाई, बट कोई बात नहीं. आई होप इट इज क्लियर, राइट? ओके, अभी तो सही है. इवन इफ you don't want, you should not even, you will not be able, you will not have to even do this thing also, because eventually you are